All right, so we are on our last section of chapter 5 where we are graphing linear inequalities. So we're going to go back to graphing some lines. Okay, graphing some lines. So let's start with, if I give you this inequality or this equation, can you find your slope and your y-intercept? And then can you tell me if 3, 2 is a solution to this equation? So think about that for a second and how you want to tackle it. Looks to me like we're graphing, so see what you can do with it. All right, so remember, if we're graphing and we need slope and y-intercept, that means I'm solving for y. So negative 3y would equal a negative 2x plus 6. And if I'm dividing by a negative 3, I get y, 2/3 x minus 2. And graphing, so there's negative 2. And I'm going up to right 3. So 1, 2, 3. And up to 1. That's too many there. Let me fix that. So we've got 1, 2, and 3. Up to 1, 2, 3. My line is going right through there. All right, so the first thing it asks me is if 3, 2 is a solution. Okay, well, let's see. There's 3 and there's 2. So here's the point, 3, 2. So is that a solution to my equation? Well, hopefully you said no, because to be a solution, I would have to be on the line. Okay, I would have to be on the line. So if I have an equation, the only points that work are actually on the line. Does anybody remember how to tell if I didn't have a graph if a point was a solution? Do you remember us substituting in and then deciding on true, false? Well, let's go ahead and try that and see what happens. Okay, so 2 times 3 is 6, 3 times 2 is 6, so 6 minus 6, 0 equals 6. Well, that is definitely false, okay, which makes sense that that would not be a solution if it actually gives me a false answer there, okay? So some of this concept is going to come into play as we're looking at a linear inequality. So I want to just review real quickly with you that we know that if something is greater than or equal to, it's a closed circle to the right, less than or equal to, closed circle to the left, and greater than, open to the right, less than, open to the left, okay? So the difference between what we've been graphing and what we're graphing now is we're moving into 2-dimension, okay? So we're no longer on a number line, we're actually on an XY axis, okay? We're on an XY axis, and we're going to see open lines and closed lines. So a closed line is just a solid line. An open line is going to be a dashed line. So a dashed or open line is going to show up. Okay, so if you look at this problem, you can see that this is an open line. And see my inequality, y is less than 2x plus 1. So this tells me that it's already open. Okay, it's already open. And let's go back to here for a second. If I was to highlight my solutions are here, okay? Again, solutions are here, and on this one, it's just that single point. When I have a linear inequality, I'm going to have a section of the graph that is shaded, okay? So these guys, anything in the shaded area are solutions. And anything in the not shaded are not solutions, okay? So that is a solution, this is a solution, this is a solution. There are lots of numbers or lots of ordered pairs that are solutions to this linear inequality, okay? All of those points will make the solution set true. Now, these points here that are actually on the line, in this case, because the line is open, these are not solutions. Okay, those are not solutions. However, if it was a closed line, they would be solutions. All right, they would be solutions. So really, the only differences between graphing a line and graphing a linear inequality is we have to decide which side to shade on, and we have to decide what kind of line we have. Okay, other than that, it's exactly the same as graphing lines. All right, so let's go ahead and take a look at this first inequality, and we're going to test some points to see if we actually have a solution or not. Okay, so y is greater than 2x plus minus 5. That means my slope is 2 over 1 and my b is negative 5. So negative 5, 1, 2, 3, 4, 5. Here's negative 5. And a slope of 2 over 1. So I'm going to make a few points here so I can have a nice graph going. And I'm going to go the other direction. Okay, now I need to decide, is this an open or a closed? Well, I see that that is going to be open. So I know my line is going to be a dashed line through that point. Okay, so far I have my line. Now I have to figure out my shading. Okay, now I have to figure out my shading. And the best point to use is 0, 0. So I'm going to go ahead and mark this point right there, 0, 0. And I'm going to test it. Okay, I'm going to test it. So I have y greater than 2x minus 5. And I know that I have a 0 and a 0. So I'm going to put a 0 here, and I'm going to put a 0 on the other side. So I notice that this goes away. So 0 greater than negative 5. Well, that is definitely true. Okay, that is definitely true. 0 is greater than negative 5. So I know that since this is the point that I tested, that side is true. So that means, okay, that means since this side was true, all of this side is my shaded region. This side is the false side. Okay, that's the false side. So nothing on this side will work, but everything on this side would work. Now, I also want you just to do some thinking about this, okay? So if this is where my line is, right here, and I put my pencil or my finger right here on this point, right on my y-intercept, okay? Put my finger right there. Where's greater than? Is it above the line or below the line? Well, greater than means up, doesn't it? So that makes sense that from this point, I would need to go up to find a solution. So that's why the up part is shaded, okay? That's why the up part is shaded. All right, let's try another one. So I have negative 3, 1, negative 2. So negative 2, and down 3, right 1, down 3, right 1. I'm going to do the opposite here to get myself a line going. Now, am I dashed or solid? Well, I see that that's closed. Okay, that's closed. So I need to have a closed line. So let me go ahead and try to get one in there. All right, there we go. So I've got my line. So now I have to decide whether or not I'm going to shade above or below. Okay, well, let's do some thinking. So if this is the point that I'm looking at, and this says less than, are you going up or down? Up or down? Well, hopefully you're thinking less than. I should be going down. Okay, I should be going down. So I should be shading on this side. Well, let's test 0, 0 and see what happens. So 0, remember we're substituting in to this equation. Less than or equal to negative 3 times 0 minus 2. This is going to go away. So really, I don't even care about that. 0 less than or equal to negative 2. That is false. So where the 0, 0 is, this side is false, which means this side is true. And I always shade the true side. So I was correct with my assumption that if my point was at negative 2 and I was going less than, I would go down. That means I'm shading under that line. All right, let's try this one. So 2x minus 3y greater than 9. Well, first thing I notice is that is not in slope-intercept form, so I better solve for y. So negative 3y greater than negative 2x plus 9, divide by negative 3, and I have to flip my sign. So I have y is now less than 2/3 x minus 3. So 2/3 and minus 3. So minus 3, 2/3, 2/3, 1, 2, 3. I go the other direction. Okay, am I open or closed? You're right, you're open. So I have a dashed line. Okay, let's put our finger on our y-intercept and let's read our problem. So y is less than. So less than should be down. Okay, should be down. So let's go ahead and test it. Again, I'm going to test 0, 0. So 0 less than 2/3 times 0 minus 3, gone. 0 less than 3. True or false? Oops, sorry, 0 is less than negative 3. That's false. And here's 0, 0. Okay, so that makes sense. This is the false side where 0, 0 is. This is my true side. So I'm shading the true side. So my guess saying I'm shading down was correct. Okay, you try this one. Solve it for y, get it graphed, check your shading, double check that you actually did your guess correctly with a test point. All right, let's see how you did. Y less than or equal to negative 1/2 x plus 3 is what you should have had for your slope and y-intercept. So positive 3, 1, 2, 3, down 1, right 2, down 1, right 2, up 1, left 2, and this is going to be a solid line. So I have a line coming right through here. All right. So less than, here's my point, less than, I should be going down. Okay, I should be going down. So let's see what happens with my 0, 0. So 0 less than or equal to, again, I don't care about that negative 1/2. I'm really comparing 0 and b. Okay, 0 and b. 0 is less than 3. Yep, that is true. So this is my true side. This is my false side. Again, I am shading the true side. So my guess if I was shading below the line is correct. All right, you're good to start your homework. Pay attention to which side you are shading on and whether you're above the line or below the line. Don't hesitate to do a test point. You can use 0, 0 unless it is on the line, okay? Because then you can't tell if it's above or below. So 0, 0 works as long as it's not on the line.